Hi, this is Ankita. This is my 4.1p task demonstration. I'll run the code in VS Code. Yeah, since you can see that the code is running fine. So yeah, the objective of this task was to extend the generic vector t by class and by implementing the binary search algorithms. So binary search algorithms basically they search for the specific item in sorted vector and return its index if found. So if the item is not present, the method returns a negative value, which is specifically is -1, or it can go for the exceptional cases. So first I will explain the vector class that has been implemented and which is followed by the test cases, which are iterative and recursive binary search. Yep. So vector t is a generic dynamic array. At the top of the class, the data is stored in an array under private t data. So the class also contains a public integer count to get the private value set, and this stores the element currently in the vector, and the public integer capacity, it represents the size of the underlying array. Then we have used a constructor that creates the array and initializes the count to 0. The first method that I have used is the add method, which inserts the elements into the vector. So when the vector becomes full, the resize method is called, which creates a new array with double the capacity and copies all the existing elements into the new array, which allow vector to grow dynamically. The class also includes several other methods like index of to find any item, contains to check if any item exists, insert to add any item in the specific position, remove add to delete the elements. Remove is specifically used to remove the element, and remove acts as at the index. Clear to remove all the elements. Sort to sort the vector. These methods provide the functionality required for managing the collection of data efficiently. Then we have used the binary search algorithms, so which is the main requirement of this task. So this method public integer, this accepts the two parameters. The first parameter is the item that we want to search for, and the second parameter is the I comparer t, which is an object used to compare the elements. The first step checks whether a comparer has been supplied, and if the comparer is equal to null, then it gives us the default case. So this ensures that a default comparison method is available if the user does not provide any one. Next, I will define the search boundaries. So integer left is equal to 0 and search integer count -1. So the variable left points to the first element and the right points to the last element. The search continues while left is less than equal to right. This means that there is still elements available to search. So inside the loop we calculate the middle position. Then we compare the middle element to the target item, and then the three possible outcomes can come. Item can be found if the result is equal to 0. Then the method will run automatically and return the mid element. In other case, it will search to the right half and then it will give us a value, and in other case, if it goes to the left, it will search for mid -1. The search range becomes smaller after every comparison. So this is what makes the binary search extremely efficient. instead of checking every element, it eliminates half of the remaining elements during each iteration. Because of this, binary search has a time complexity of O log n, which is significantly faster than a linear search which has a time complexity of O(n). Now I will explain the tester cases in this. So tester, we have created an array of 20 integers where the data is compared into two kinds like ascending and descending, and 6 tests has been performed. Test A search for the value 333 in an ascending sorted array. Test B searches for the value smaller than the minimum element. Test C searches for the value larger than the maximum element. Test D searches for 333 in a descending sorted array. So the expected result in all the cases are displayed to be success. So when I run the program, all the 6 tests pass successfully, confirming the binary search implementation works correctly for both ascending and descending sorted collections. So there are two common implementations of binary search. First is the iterative version, which is used in a loop. So this approach can be implemented in my solution too, and because of that it has lower memory usage, faster execution and simpler runtime behavior. The second approach is recursive version. In the recursive version, the function repeatedly calls itself on a smaller portion of an array. Although recursive code can be shorter or easier to understand conceptually, but it is using additionally high memory because of each function which is called, it is stored in a call stack. So but both of them have same time complexity of O log n. So at last we can say, like, I have successfully got the generic vector T working, and my solution explains that all. Thank you.